Hi everyone, this is Kalyan Kumar this side and welcome back to Chemistry Universe. We are doing biomolecules in which we are doing carbohydrates and this is video number 5. And in this one we're going to do the monosaccharide glucose. And in glucose we're going to do the preparation of glucose. There are industrial methods and lab methods. And then we are going to quickly look at the physical properties of glucose. This is going to be a very short video. So let's get on with it. All right, so let's see glucose, which is C6H12O6. It's also aldohexose. It's an aldehyde in the open chain form. Now, glucose is known as dextrose because it occurs in nature as an optically active dextrorotatory isomer. Now, this is very important to understand. Glucose in nature is found as D-glucose. Now I'm talking about capital D. Okay. So in nature it occurs as capital D glucose. And as luck would have it, it is also dextrorotatory. Remember, capital D has nothing to do with dextrorotatory or levorotatory. But in the case of glucose, by coincidence, the D-glucose, the capital D-glucose also happens to be the small d-glucose, dextrorotatory or plus glucose. In nature, it is only found as this. If you want to make the levorotatory one or the enantiomer of this, it has to be synthesized in the lab. It does not occur in nature. Now, it is called as grape sugar as it occurs in large quantities, about 20% in ripe grapes. Even though most of the fruits contain fructose, but grapes contain 20% of glucose. Now, it occurs in most sweet fruits and honey. And it is an essential constituent of the human blood. The blood normally contains 65 to 110 milligram of glucose per 100 ml, hence named blood sugar. So, when we talk about blood sugar, in diabetic patients or even in normal patients, it doesn't actually mean you're looking at sugar in terms of sucrose. You're only looking at glucose, the level of glucose for in milligram per 100 ml of blood sample. And generally, anything above 100 or even probably 110 milligrams would constitute a person who's having a tendency to have a diabetes. But generally, anything below 110 is considered usually normal. And this range also fluctuates. It fluctuates from patient to patient. So people who are suffering from high diabetes, for them even getting a 120 could probably be a normal one if it is fasting. All right, let's look at the preparation. Well, the lab method. And it is prepared in the lab by the acid hydrolysis of cane sugar in an alcoholic solution. So you have a cane sugar, C12H12, H22O11. This is cane sugar. You do hydrolysis. And then you do acidic hydrolysis. And you end up getting the constituent of sucrose, which is glucose and fructose. They both have the same formula. They are isomers. And they're functional isomers actually, but they have the same formula. If you want to look at the industrial method, well, it is obtained in a large scale by the hydrolysis of starch, that is cornstarch, on boiling with dilute sulfuric acid or HCl at around 393 K under 2 to 3 atmosphere. So you have starch, which is a polymer, it's a polysaccharide, and you do acid hydrolysis and you will get glucose. And so let's look at some physical properties of glucose. Well, it is a colorless crystalline monohydrate, C6H12O6.H2O. So it is crystalline and therefore it has a water molecule inside the crystal lattice. It is highly soluble in water, sparingly soluble in alcohol, and completely insoluble in organic solvents like ether. It is less sweet than cane sugar. Now, first of all, you need to understand that is that its solubility. Solubility is pretty high in water because of several OH groups. So it can form a good amount of hydrogen bonding, which is why it's not that soluble in the organic solvents. And it is less sweeter than sucrose. So glucose by default is not as sweet as sugar that we generally consume. It is optically active, and the ordinary naturally occurring form is plus glucose, which we already discussed. And it shows mutarotation, which is the characteristics property of reducing sugars. Now, mutarotation is something that we'll see later on. Basically, what happens is when you do the hydrolysis, you will find that it is going to if you remember the Haworth projection, so the alpha and the beta form interconvert, and they have different optical rotations. Not only the direction of optical rotation can be changed, even the values are different. So that is generally called the inversion of cane sugar, but that we will do later on. So that sort of finishes off the monosaccharides, preparation and physical properties of glucose. So with that, we come to the end of this particular video, and just go through it. It's not much. There are not that many reactions in this, and but you will be getting a lot of reactions shortly because we've done physical properties. So the next round would be chemical properties. Till then, have a nice day, and thank you for watching this.